lecture. We are going to learn about inheritance and polymorphism, and along with it some like small minor topics that you guys already know from your Java experience. And I'm just going to open the thing that we had in our previous lecture, the code that we had in our previous lecture about the student class. So this was the code that we had in our previous class. If you look at this, we had the student class here, which had a name and a year of birth, and we had all these public like methods, which are the member functions. We call them as member functions in C++. The first thing is the constructor, and we had like the getter method for name, the setter method for name, the getter method for year of birth, the setter method for year of birth, and a print student method. This is what we had, and this particular part of the student class is called the interface to the class. If someone is going to use this particular class, all they need to know is what are these functions, that is our public functions that are available to them. So the clients only need to know the interface of this particular class. And so this particular part of the class is in the .hpp file, and we have the actual implementation of all those methods in the .cpp file. And the main, like one main thing about syntax we saw here is like whenever you want to like say I'm going to implement the method getName, you will have the name of the class prefixed to it with the scope resolution operator, the double colons, and say this is the name of this is the method that I'm going to implement from this particular class. And all these things will come under the CPP file. And to use this, we had something like, okay, we created a student S1, and then we just set the name of the student and the year of birth of the student, and then we just printed the student. So now let's just try running this and say it says like classes in C++ and name is Varun and year of birth is this thing. Maybe you can just add a space, like a new line here, because we'll be printing multiple things today. I'm just adding a new line before the name and the year of birth is being printed. Okay, so the name of the student is Varun and the year of birth is 1992. Okay, and then what we are going to do today is first talk about, like, before we even move to inheritance, we're going to just talk about some data members that are not that belongs to the entire class. So, for example, if you want to have like a number of students, if you want to have a number of students that have been created from this particular class, how do you do that in Java? Static. We use the keyword called static, and that's exactly what we will do in C++ also. So in this particular case, in the student.hpp, the name and the year of birth belongs to each and every student. Whenever you create a student, that student should have a name and that student should have a year of birth. But a field like num students does not belong to each and every student, but it belongs to the class as a whole. We think of our class, and the number of students in our class is 116. That does not belong to each and every one of you, but it belongs to the class as a whole. So in a similar way, very similar to Java, when you want to have some variable like that, you prefix the keyword static. Static just means this belongs to this particular data member belongs to the entire class, and it does not belong to each and every object of this particular class. You say static in num students. Okay. And with this, if you want to create so first let's just have this, and then here whenever a student is going to be created, we should increment that num students, right? But usually static data members, and also since this is also integer, we saw that in last class when the year of birth was not initialized inside the constructor, it had some junk values, right? So it is our responsibility to actually initialize the num students and then go and increment the num students whenever a student is being created. So in C++, whenever you want to like initialize a static data member, you go to the CPP file and just even before like any of the things done, or like as the first line here, you just have int, okay, student num students is equal to 0. It's never used. Yeah. So we have like num students is equal to 0. So see here in the CPP file, immediately after the hash includes, we are having this particular thing. We are saying like we are initializing the num students to 0. And the initialization of the static members should happen only in the implementation file. Okay. And you should not have this particular line in the header file, because only when someone is going to create an object of this particular class, this initialization should happen. And once this happens, what will happen here, since it is a static member, you can just go inside and then just say I'm going to increment. Again, this particular thing is, since this is very similar to like how we had in Java. In Java, if you want to have access like static members, you will say the name of the class dot the static member name. Is that correct? In a similar way, here you just say the name of the class and the scope resolution operator and the static member name. So every time a student is going to be created, you are just going to increment this count of the student. Okay, it's going to be plus plus student num students. The num students variable inside the student class. And if you want to like get write an accessor for this particular static data member, you go here and just say static. Okay, this static here means we are writing a data member function that is a static member function. This member function does not belong to each and every object, it belongs to the entire class. So static, and it's going to return an integer, and let's say get num students. Okay, and then if you want to actually implement it and say generate definitions, yeah, the definition in the CPP file is it asks you what should I return for this particular thing. All we have to return is the num student static data member. That's it. And now in main.cpp, if you go and let's say create one more student, or first let's say, yeah, let's maybe create one more student like S2. So if you see here, the two students are printed here, okay, and then what we're going to do is like just try to print the number of students that have been created till now. So CO is equal to, so we're going to call the get num students from the student class, right? Again, since it's a static data, since this is a static member function, we will prefix the name of the class and just say get num students, okay? The scope resolution operator, and since it is a public method, it can be accessible from the main function. So when you press this, so you see here the num has been printed as 2. That means there are 2 students that have been created, or there have been 2 students of this particular class that has been created. Okay, any questions about static? Yeah.
Could we just print the variable directly in this, since it's in the same class? Does private affect it if it's in the same class?
I'm not sure if I understand the question. Can you repeat it?
Variable num students is in students in the students class.
Yeah.
Can we print it directly in the students.cpp file?
But the num students that you have here is like a private data field. Private data field, so you cannot access it directly. So that is the reason why we have a public member function to access it. So if you want to, like, if you are trying to access that private data field directly here instead of get num students, if you just say num students, it will not even be accessible here. It says like num students is inaccessible. If this is what you're asking for. Yeah, so that is the reason why we cannot print num students directly in the main, because the main is a client of that particular class, and num students static data member is actually a private data field there. So instead of that, we have used the public member function to access this, and this is how it works. Okay, and you can use this particular aspect of the static, which actually has only one value for the entire class. to assign like unique student IDs. You can create a field like in ID, and whenever a new student is created, you can use that num students variable to actually assign that student ID. Does that make sense? Because that keeps track of how many students have been created, and each student, if it is just a monotonically increasing sequence of student IDs, you can just use that static data field to assign a student ID. You will be doing that for your A3 that has been released. And for A3, both the partners need to actually fill out the form. If only one of you fills out the form and the other doesn't, then we will not consider that as a team. We will think that maybe the other person does not want to work with this person. Okay? So please, both of you fill out the form if you want to work as a team. The deadline is today, like before midnight. And after this, we just saw static now. So we just saw these two things, static data members and the static member functions. Now let's see something about like parameterized constructors. So when we created the second student, what if we want to like do something like by creating the student itself, we want to give the name of the student, and then the year of birth of the student. We don't want to use the set students unnecessarily. If this is one way that you want to create a particular student, then you have to have a special, like another constructor which takes in both the name and the year of birth of the student whenever the constructor is being called. So I go to student.hpp, first add that type of constructor, which takes in a std string, name, and the year of birth, okay? And this constructor, now we want to like define this particular constructor and generating the definition for this. Yeah. So inside the class, inside the CPP, we have this definition of this constructor, and I'm going to move it to the top. After this, this is called no argument constructor, and this is called parameterized constructor. Okay. And this thing here we will be saying, okay, whenever someone creates a student object with two parameters, name and year of birth, immediately create that object with that particular name. So here you will be saying student, the name, the data member name is nothing but whatever name is coming from here, and the data member year of birth is nothing but whatever the year of birth that is coming from as arguments to this particular constructor. And we should also remember to increment the number of students. So a student may be created in any way, but whenever a student is created, we should increment the number of students. So we should also have this line of code here. And so we have created a parameterized constructor. And so now in main.cpp, this line of code should work. Okay. So now let's just try this again. You see here, first Varun was created with the no arg constructor, and then we specifically set the arguments of using the setter methods. We just set the name and the year of birth. But for the second student, Haley, we have like a parameterized constructor. Whenever we are creating the student object itself S2, directly we are passing in the name and the year of birth. Okay, I think this is straightforward. Whatever, I think you would have learned all these things in Java. Okay, now we go to like much more like cool stuff. First one is the inheritance. Okay. Again, this is like we have a student class. What if you want? You have a question?
I was just wondering, can the original constructor call the parameter as one, passing the parameters no name and 0?
Yes, S1 when we are creating student S1.
Yeah.
So when we are creating the
and the one without parameters simply just call the one with parameters.
Yes, that is possible. So the question was, when we are creating the constructor without the parameters, can it simply call the constructor with the parameters with these things, okay? With no name and 0 as the parameters. Yes, it is possible, okay? We can do that, and if time permits, I can show you how to do that. And yeah, with that particular thing, yeah, inheritance. So we have a student class, and we know like if we are going to specialize multiple like different classes from the student class. For example, undergrad student and a grad student who may have different properties when compared to a normal student. The normal student will always have a name and a year of birth, but an undergrad student may reside in a residence hall, but a graduate student may not. A graduate student may have a research area, okay? But an undergrad student may not have a research area. And so, if you want to like specialize these things, then first we go and create, okay? Again, I will not be like motivating why we need inheritance. I'm just showing you how to use inheritance in C++. Okay. And let's say this is undergrad student. We create undergrad student class, and we have the HPP and the CPP here. And in C++, if you want to like inherit some class, if you want to say this is a derived class of, or this is a child class of some parent class, you will say public, the name of the parent class, which is the student here, okay? And the student.hpp should be included here. You want to use the student class. So this is the syntax, the colon, the name of the class, the colon, and saying like I'm publicly inheriting from this particular student class. There are different types of inheritance in C++, which we will be not going through in this class. They are like protected inheritance and private inheritance, but that's also not so useful in real world code, okay? So mostly we'll be using public inheritance, and this is how you publicly inherit from other class. By publicly inheriting, it means that whoever is using the undergrad student class, all those people, all those clients will know that undergrad student is actually a child of the student class, okay? This is how we inherit. Now the data member's name and year of birth automatically is there inside the undergrad student class. And so the one different thing that we are going to have in the undergrad student class, let's say we will have a private, and the one different thing is, let's say, the residence hall, okay? We have a residence hall, which a general student does not have, okay? And then we have a public fields, and first thing that we want to create here is like a constructor. So if I want to create an undergrad student constructor, the constructor is going to take it. I'm only going to write the parameterized constructor here. So the name of the student, then the year of birth of the student, and then also along with that residence hall, okay? Let's say R hall, residence hall of this particular student. And then if you want to implement this particular thing, the definition for this. Now inside the undergrad student.cpp file, we have this undergrad student, and I'm using more space now. So I'm moving these things and just formatting these things like this. Yeah, and in undergrad student, okay, if you are creating an undergrad student, the first thing here is whenever we are creating a derived class, first thing we should create the parent class part of it, or the base class part of it. This is like a basic concept in inheritance. So whenever you're creating derived object, the parent part of the object should first be created, and then only the derived part of the object should be created. What I mean by that, I'll just try to like draw stuff here, if this is visible. So let's assume if you are creating just a student, okay, a student object, let's say student S1. Okay, we're creating just a student. What will happen here is the student only has a name and a year of birth. These are the only two fields that a student has. But if you are creating an undergrad student, let's say UGS, okay, undergrad student, undergrad 1, okay, this is the undergrad student object. Then whenever undergrad student object is created, first the parent part of the object should be created. By that I mean, whenever a class is derived from some other class, there are two parts to that object. Okay, the first part is called the parent part, or the base class part. This is the child part. Okay, you may use anything that you want. Base, derived, parent, child. Okay, so the parent part should be first created. By that we mean we should first create the name and the year of birth for this particular student, and then go and create the specific fields that are available for this particular undergrad student, which is just the residence form. Okay, so this is common for everything. So in Java, how would you create the parent part of an object? Do you remember? Anyone? Yeah.
You use super.
Very good. We use a special function or method called super. Whenever you just call super, the parent part of the object is created. Okay, and then we go and create the child part of the object in the constructor. In C++, we don't have any keywords like super, but to create this parent part of the object, which is like this part, okay, which is this whole part, what we are going to do here is we have something like member initializer list. Okay, the syntax for that is, so maybe I will just have it like this. Okay, so even before the definition of the constructor is going to be executed, okay, we have a colon here, okay, we have a colon. This is like some different syntax that you would not be used to. I'm just taking some time to explain this. So you have a colon here, and after that colon, you call the parent class's constructor, because the parent class will automatically create the parent part of the object. So the parent class is just student, right? You give the student and you pass in the name that you get for this undergrad student and the year of birth of this undergrad student to the parent class directly. So this particular piece of code called the member initializer list will be executed even before the actual body of the constructor is executed. Does this make sense? So even before the specialized part of the derived class object is created, we actually create the parent class object. This is very similar to using super. Super should be the first line in any derived class constructor. If you remember Java, you remember that? Very similar thing. Even before the actual body of the loop, body of this constructor is executed, we have to create the parent part of the object and then come inside. And the syntax is just like this. There's nothing else. And usually you will not see like this. You will see like right here. Okay, you will see it right here. And even this column will be like this. Okay. But that means it's a member initializer list. Okay, we have this member initializer list, and then inside this you just only create the derived part of the specialization of this particular class, which is just the residence hall. Just say residence hall is equal to R hall. That's it. So now in the undergrad constructor derived object, we first create the parent part of the object and then create the derived part of the object, which is just this. Now to check this, we can. And if you want, you can like have a get residence hall member function if you want, okay? But I'm not going to write that. I'm just going to write like a print student. Okay, print student member function, or like what was the? We will use the same name that we had here. Yeah, we had like a print student in the student.hpp. I'm going to have like a print student for this particular thing, which is a void. Okay, void print student. This is going to print the details of an undergrad student. And to print the details of an undergrad student, what we can do here is like, we just say, generate the definition for this. And when we are printing the undergrad student, the first thing that you will be printing, this was auto-generated, but I'm just going to like delete that. When you want to like write a definition for a print student of an undergrad student, you know that already you have a print student function in your base class. Okay, first you should call that particular function just to print the name and the year of birth of this undergrad student, and in addition to that, you will just print the residence hall for this undergrad student in this particular method. So how to call the member function from the parent class is, let's say, print student. Okay, you call the print student method or the function from the parent class, and in this version, just along with that, just print one more detail, and the detail is copying this from here, and the detail is going to be residence hall. Since we don't have a get residence hall, I'm just going to directly call the residence hall for this undergrad student, the data member. So this is how you create a print student. Now if we go to the main, and if you want to create an undergrad student, okay, let's say your undergrad student, let's say UG1, and since we have a parameterized constructor, we can directly call this parameterized constructor right here, okay. And we have to do the residence hall here. So now this undergrad student will be created, and if you print the type of this undergrad, like the print method of this undergrad student, let's see what happens. So if you see here, the print method for undergrad student first printed the name and the year of birth, and these two are printed by just calling the parent class's print student method. And the last detail, residence hall, we explicitly printed that inside the print student method. Any questions about this? So the things that we just learned right now, how to inherit from a parent class. And then we also saw something about the member initializer list. I think the only new thing or like the syntax that is different from Java here is this member initializer list. which creates the parent classes object, and then you go and create the child classes object. And one more cool thing here in the member initializer list is even this particular residence hall that you are initializing for the student class, you can also make it a part of the member initializer list. I'm going to write the member initializer list like this again, like we had it previously. So if you want, this particular line can also be moved to the member initializer list, like you can just say, comma, in this member initializer list, you can even just say, comma, residence hall, I want to initialize it to this R hall. This is also a valid thing. So usually in most of the constructors that you see in the derived classes, the body of the constructor would be just empty and everything they would have done in the member initializer list. In this member initializer list, what happens is we are saying first create the parent part of the object and also initialize the residence hall of the child part of the object, R hall. And so we don't have any code inside this, and most of the real world code bases you will see code like this. Almost all the members will be initialized just using the member initializer list because there is some slight performance reasons, in the sense just like if this particular member initializer list is like highly performant than actually having it inside the constructor. Okay. So you will see like this is just a syntax. Any questions about how do we inherit from parent class, or how do we create a child class object in C++? Anything about whatever we just discussed right now? Okay. This is straightforward. And then we also saw member initializer lists. So I would definitely recommend you to go back and read this from CPP reference, the member initializer list, because this is like one important concept, and yeah, understanding this is like very important. And then now we are going to look at polymorphism. How do we implement polymorphism in C++? If you remember, polymorphism is like that would be, let's say, method. The method may take a student object, but based on the type of the student object, if it is undergrad student or grad student, it will just call the corresponding methods inside those classes, and we need not worry about what particular type of the student that we are passing into this method. At a high level, this is what polymorphism is. So to understand polymorphism, maybe we should create like grad student also along with this. Okay, let's just create one more class, like grad student, and we just like copy and paste this code that we have here. So instead of a residence hall, this grad student is going to have, let's say, research area. Okay, and here we are saying this grad student is also a child of the student class. Okay, this should be a student.hvp. Okay, and then here instead of undergrad student, there should be just grad student, constructor for a grad student. Instead of residence hall, it should be like the research area, area. Okay, and all other things remain the same. And in the CPP file, again we can just copy it from the undergrad student CPP file, whatever we have here. And just make it like a grad student, okay? Grad student. The name, year of birth, everything remains the same. And here, instead of residence hall, it's going to be a research area for the grad student. So research area is going to be initialized to our area. Okay, and with this, again we have this print. We are going to also have a overridden, not overridden. This is just a print student method, and then instead of the residence hall, we just have like research area here. We print the research area for this grad student. Okay, so now we have a grad student class also, which is also a derived class from the undergrad student. And in main.cpp, now we can create a grad student object. Grad student. Say G1. And the research area, say like operating systems, okay? And if you say like G1 dot print student, now it should print the details of the grad student. So now if you see here for undergrad student, it just printed the residence hall, and for the grad student, it called the actual print method of the grad student, okay? This is fine. Now, what if we want to create a method inside the main.cpp, okay? We want to create a method inside the main.cpp called print student, which takes in a student object, okay? Which takes in a student object, and irrespective of the type of the student, should call that particular print student method inside the student object. This is what we want right now. And to achieve that, so first let's just write that particular method, okay? So the method that we are talking about in the student here is like, okay, maybe I'll just write it on top as of now because I don't want to write the declaration again. I'm going to write a print student method in the student.cpp. Maybe you can name it differently because it may confuse the print student that we have here. Let's say print detail, okay? Print details, okay? Print details of a particular student. And this student is going to be passed in as a reference, like a student reference, okay? And this is a void method, okay? So we already learned why do we pass in by reference, because when we pass in by reference, you need not pass in the whole object as it is, but you just pass in saying like, okay, this is the object that I am using, so the object will not be copied unnecessarily, but the same object that is in the main will be used inside this print details method. And to have this, okay, to have this student, okay, we assume we have a reference to a student which is sref, and this method just tries to call sref dot print student, okay? It does not care about what type of student it is, but just calls a print student for that particular class. Now what will happen if we call this print details method on, let's say, the undergrad student 1, and then maybe again on the grad student 1 that we just created, who have like specializations of the residence hall and the research area. Can someone tell me now what will be printed when we call print details on undergrad student and the grad student? Just any guesses? Yep.
We'll call the method that's in the objects class. So like I'll call the one for undergrad and one for grad student.
Yeah, so the answer was, okay, it will actually go and call the print student, because inside the print details method, it will go and call the print student of that particular class. If it's undergrad student, it is going to call the print student of undergrad student. If it is a grad student, it is going to call the print student of a grad student. Let's see if that is the case, okay? Just going to run this. So see here, initially when we just printed with the object itself, we actually printed, you see, with the, what to say, residence hall and the research area, but the last two prints that we printed inside that method only printed the parent version of this. Can you see this? Only printed the parent version of the print student. And the reason for this is, in Java, okay, in Java, usually whenever you have the same method, let's say print student in the parent class and print student in the child class, it is automatically overridden, okay? The base classes version of like print student is automatically overridden in Java, but in C++ that's not the case. Even though the methods have the same name, okay, it's not automatically overridden. We have to explicitly mention that this particular method is just to override of that particular base class method. And so to do that, the keyword that we have is called virtual. So this print student in the parent class should be declared as a virtual, and this keyword will only appear in the header file, in only the interface or the header file, okay? It will not appear anywhere in the implementation file. You just have the virtual keyword here, and once you have virtual keyword here, it means that now the derived classes can actually override them. So here also you will have like a virtual keyword, and you will say the keyword override at the end. This is actually not necessary. Even without this keyword, your code will work properly. But for programmers, when we are going and looking at that, we will easily understand, okay, now this has been overridden. This override at the end is very similar to you give at the rate of symbol and override in Java. If you remember in Java, whenever a derived class has an overridden method. On the top of it, there will be annotation called at the rate of and override. Okay, even if that is not there, your Java code will work. In a similar way, even this particular override keyword is not here, your code will work. But this is very useful when programmers are like reading your code. So now we are seeing this is an overridden method from the parent class. And in the same way, you go to the grad student and say this is also a virtual method which I am going to override from the parent class. And now once you do this, now if you go and try running this, let's see what's happening. Now do you see this? The last two prints that are happening are actually printing the corresponding versions of the grad student and the undergrad student. Is everyone able to like understand this? Now once you added virtual, it means that now whenever, now after adding that virtual, I'll explain what is happening here. We call the print details, okay, with the undergrad student object. And even though this object is undergrad student, the print details method does not worry about it because the print details only takes a reference to the parent class object, which is a student, okay, which only takes a reference to the parent class. So according to the print details method, all it knows is I am getting a student as input. All I need to do is just print the details of the student. I don't worry about if it's a grad student or undergrad student or any type of student. I just go and call the print student method on that particular student object. And inheritance is a relationship, is A. So undergrad student is a student, grad student is a student. And so when the sref calls when we call the print student on the student reference, automatically that sref is just pointing to a undergrad student object the first time it is being called. And so the print student method from inside the undergrad student object will be invoked, will be called. And that is the reason we see the residence call being printed for the undergrad student. And then the second time, when we call the same function here, print students with the graduate student object G1 that we just created, which has a research area. Now when we go here, this print student method, okay, is calling the print student, the overridden print student method inside the graduate student class. That is the reason we see this research area here. And so we just created a polymorphic function right here. The print details function in the student in this main.cpp is a polymorphic function which takes a reference to a student. It can be any student, and whenever a particular type of student is passed to it, it calls that like the virtual function for that particular type of student object. And this is the core base of polymorphism. And once you understand this, you can do like so many magic in C++. Any questions in polymorphism?
Yeah, it's not about polymorphism, but with virtual and override things, are those only in the header file?
Yeah, the virtual and the override, those keywords are only in the header file. If you see here, we did not modify any of the things in the CPP file. The implementation files remains as it is. If you see a print student, there is no virtual or no override. Those keywords are only in the header file to inform the clients that are using our class to make sure that this is the virtual method. So be aware of it in the sense. Whenever you call a particular print student, you call the print student of that particular subtype. And so no keywords like virtual or override will appear anywhere in your implementation files, because automatically the compiler can understand it from your header file and will attach all those things here for you. And you should not have it actually here, okay? Any other questions? Yeah.
This isn't necessarily about polymorphism, but when you're commenting and you get function headers, does that go in HTTP file or?
That's a good question. Since we split the files into .hpp and .cpp, if you want to write like headers for your functions that you're writing, okay, it should go in your header file, because those details are mainly for the clients to understand what your function is doing. So it should go in header files because only the header files are accessible to the clients. Here, since we are creating everything, we have access to everything, but usually only the header files will be accessible. And so, like, you will have all those things in the header files, and there will be no function header comments in your CPP files, but you will have the implementation comments. Here, I'm not writing any implementation comments, but usually there will be like implementation comments. What are you trying to implement? And even for your A3, you should write implementation comments in your CPP file. Okay, and whenever you have a overridden method, okay, let's say the print student, if you're writing comments for that, usually that comment will only go in the base class. You will not have a function header for print student in the undergrad student or a grad student. You just ask them to refer to the, usually it's the convention to refer to the base class to see what that particular function is doing. Yeah.
In Java, we had like abstract classes where you had to override certain functions. Is there something?
That's great. Yeah, that's the next thing that you're going to see.
Cool.
Awesome. So the next thing is, in the same way, okay, we saw this thing, particular thing. If we are going to write a method called, let's say, get type of the student. Okay, so in the student class, I'm going to have a method called get type, which is going to return if the student is a graduate student or undergraduate student, and this is going to return std string. Okay, this is a public method. But if you think about it, what does it mean to have a function called get type in just the parent class student? There's no idea, right? We cannot just say normal student or general student or something like that. You have to have this, the implementation of this get type function only in the derived classes, but there should be no implementation in the parent class, because it doesn't make any sense to have a function like this called get type in the parent class, because at that time you don't even know what type of student the student is. And so in Java, you will make this particular function an abstract method. Okay, this particular method an abstract method. And once you make this particular method abstract method, immediately a whole class becomes abstract class. You cannot create objects of that particular class. In a similar way, in C++, to make it an abstract method, again you just add the virtual keyword, okay, and at the end you just give equals 0. That's it. This equals 0 just means this particular function called get type will have no definition inside the parent class, okay, making it an abstract method. And we don't use the word abstract in C++, but this particular type of function is called pure virtual functions. Pure virtual functions. And once you have even a single pure virtual function inside your class, immediately that particular class becomes an abstract based class or abstract class. That means you cannot go and create an object of that particular class. So now if you go to our main.cpp, let's just try running this. Do you see this? So since in our main.cpp we have already created a student here, okay, it does not show any error here, but when you run it, it finds out that okay, now this has like a pure virtual method, and so there is an error immediately at line 15 here in this line. Error variable type student is an abstract class. So you should understand from this particular error that oh okay, then that particular student class has a pure virtual method. So hereafter it is not possible to create an object of type just student. Either you should create an undergrad student or a graduate student. So hereafter the initial part of our code is invalid. So this particular code in our main.cpp will not work. So I'm just going to make that comment that out. Okay. I'm going to comment this out, and now let's try running this. See here. Now there is one more error saying like variable type undergrad student is an abstract class. Because okay, why it's saying like the undergrad student is also an abstract class? We just inherited from this particular class. So this particular undergrad student has got all the data members and the member functions from the parent class. But we have mentioned that the get type method is a pure virtual function in the parent class. And currently the get type is also a pure virtual function inside the undergrad student class. You have to explicitly define the get type method. Unless you define, this is very similar to in Java, if there is abstract method, you have to write a definition in the derived class. If you remember that, in Java, if you have abstract method in a base class, you have to define that in all the derived classes. A similar way, here you have to define the get type method. Unless you define that, your code will not work. So here I am going to say, now this is again a virtual method, which is get type, okay? But I am going to write the definition. This is overriding whatever I have from the parent, but I am going to like write a definition for this particular thing. So generate definition, yeah. So we did not do the return type. The return type is std string. Okay. So I have this here, and in the undergrad student or CPP, say this is std string, and for this the type is undergrad student or just undergrad. Now when we run this, even we have did this, see here, the grad student we have not, since we just did it for undergrad student, but the error is, the grad student is abstract class because we still did not define this method in the grad student class. I'm just copying and pasting this particular method in the grad student class, the grad student.cpp. You should also add it in the grad student.hpp. Okay, so this is not undergrad student, this is the grad student hereafter. Okay, in grad student, get type is going to be, just let's say grad. Okay, and we should also have a very similar to say the function declaration in the grad student header file. We have this get type right now. So now when we run this, okay, see here, now our code executes, and if you want, you can easily now go and add this get type, okay, inside your print student. In your print student class, now you can just add the type of the particular student whenever you want. So in the print student, after the research area, now I can just say type is equal to we have like what is that, get type, right? I just call the get type method, and I also add the same line inside the undergrad student print. So now let's see, let's run this again. Now do you see here, for the undergrad student the type is being printed as undergrad, and for the grad student the type is being printed as grad. This is all about the abstract base classes or the pure virtual functions that we have in C++. So again, I'm repeating it again, if there is a pure virtual function in any base class or in any class, that particular, even with just a single pure virtual function, that class immediately becomes an abstract base class, and you cannot create objects of abstract base class. So you have to define the methods in your, you have to define those particular pure virtual functions inside your derived classes. Unless you define them, write a definition for those methods, your class still remains, those derived classes also still remain an abstract class. Okay, so you cannot create objects of that particular class also. I think we are done with today. Please, if you have some time right now, and please spend like 5 minutes to just do the course evaluation, or even after going back. Please, the deadline for doing this is like tonight. So I please recommend you to do this, because we really need your input about like how this course is going to be like organized in the future for next semester. Okay? Thank you guys, and if you have any questions, please feel free to like come talk with me. And remember, start working on the project. We would like to see some actual code for the project. Okay? We just don't need some ideas.